In this segment of human capital investment, we're going to take a look at the actual equation and the metric that we use to value human capital. You'll realize that this equation, when you take a look at it, is nothing but a present value equation and really has to do with something akin to the income and production valuation method of capital. So let's take a look at this. The present value equation operates off of a number of different variables. Its form is present value is equal to the sum of beta t over 1 plus r to the t. The sum of beta t over 1 plus r to the t. So we have a number of variables here, of course. We have PV itself. We have beta. We have t. We have r. Unsaid here, unspoken, unrepresented in this particular form, is some concept of future value. Well, let's look at what each of these means. PV, of course, simply means present value. Beta is some change in payments or stream of benefits. T is a variable for time. R is a variable for rate, sometimes referred to as a discount rate, and FV, of course, is future value. Any of you that understand the present value, future value, time value of money equations are familiar with these 5 variables, although you may think of them as present value, payment, time, rate, and future value. But it's the same thing. We actually have 2 forms of this equation. The first form I've given you is the summation form. This large E-looking symbol is intended to be a summation, so equaling the sum of beta t over 1 plus r to the t, in which case the t in the denominator is a time variable that's used as an exponent. The r is the rate variable that's expressed in its decimal equivalent, so 5% would be 0.05. In the numerator, the t is simply a subscript. It's not an operator at all. It doesn't do anything. It just helps us identify this stream or change in payment at the same time that we're evaluating for the t in the denominator. There's a simple version of this, which is really just the same, slight difference, that is present value is equal to simply to beta t over 1 plus r to the exponent of t. Well, as you can see here, since this is not a summation, this is a one-shot event. So we can do present value at one point in time, a stream of payment, stream of change of payment at one point in time, and 1 plus r at one point in time. Whereas the summation equation we can use for a number of points in time. So as we go through this segment, I'm going to suggest that you review this and then you listen to this segment again. It's going to get a little bit technical, but once you get the hang of it, it's just the same term repeated over and over again with slight variation. Well, let's look at how this present value equation is created. What we're really looking at, if we look at this simple form, what is the value in today's dollars, the present value, if I receive some payment or benefit at a time in the future, and I have a interest rate expectation of R, and where T is equal to time. So let's assume for a moment that I want to identify the present value if I receive a $10,000 benefit in the future, and if I have a 5% expected rate of return, and I'm valuing this at 4 years. So my R is 5% or 0.05. My beta T at the 4th year is 10,000, and my year's time variable is 4. Well, as I look at this, this is simply a term that I can calculate simply with a calculator that is going to tell me that it is $7,835.26. So in this case, $7,835.26 today, if I invested that or if I loaned that to someone, I would get $10,000 back in 4 years, assuming that my interest rate expectation was 5%. So it's just a way of giving us a time value of money calculation. So if we want to think about this just a little bit further, we can then consider, well, what if I receive $5,000 for each of 2 years? So present value is going to equal 5,000 over 1.05, let's say to the first, plus 5,000 over 1.05 to the second. So I'm getting $5,000 at the end of the first year, which is the same thing as the beginning of the second year. And I'm getting another $5,000 at the end of the second year. And I'm expecting a 5% rate of interest. What is going to be my present value? Well, if I think about this, 5,000 divided by 1.05 is simply $4,761.90. And then another 5,000 divided by 1.05 squared is 4,535.14. If I add those together, I then see that I got 4761.9 plus 4535.14, or $9,297.04. So if I will invest $9,297.34 today at 5% interest and receive a $5,000 payment for each of the next 2 years, I will end up getting the sum of $10,000 over time for my $9,297 investment today. So that's a simple way of looking at this. And here we've used the summation form because it's the sum of each of these years. Well, let's think about this as we are going to as we consider the human capital equation. Here I've simply identified our present value, future value, time, rate, and such. And here I've expressed, maybe a little more cleanly than I'm able to do with my own handwriting, the summation equation. But let's talk a little bit about what this stream of payments means, and let's talk a little bit about what R means, and then how we compare present value, or how we assess this once we've come up with a value in this. So in this case, I'm going to suggest that in our stream of payments, we're looking at a change in some financial value. So let's assume if I'm looking at my college education in this, in the first 4 or 5 years of my education, my change in value is going to be a negative because I'm making my investment. I'm putting in my costs. So let's say I have $15,000 of tuition each year. That's a negative $15,000. Let's say that includes my tuition and my books. That's an expense I would not have had were I not making the investment. Let's assume that I was earning $25,000 a year before I decided to go to school, but that while I'm in school, I can only earn $7,500 because I'm working part-time. So I've got a decrease in income of $17,500. That's a hard cost. That's a dollar value that I would have had I not been making this investment, and I don't have it since I am making it. So that becomes part of my overall cost. And as I'm building up my costs and benefits, I'm looking at the change in my financial experience during these years because I'm making the investment. And when we're in school, when we're in college, the change is typically a cost or a negative value. So I'll sum those up, in which case I would have my present value being equal to the sum of $32,500, that's the $15,000 tuition and books, plus my $17,500 of lost income, over let's call it 5% to the value, or to the exponent of 1. That would be the expenditure during my first year. Well, if I'm looking at that, I've actually got that expenditure for 4 more years. So I'll just represent that by ... and then negative 32,500 for each of the next 4 years, 1.05 to the fifth. So I've accounted for 1, 2, 3, 4, 5 years, $32,500 a year in costs during those years, which were my tuition and books of $15,000, my lost income, my opportunity lost income of $17,500 for a total of $32,500, and this is going to end up giving me my costs. Well, if I think a little bit further about this and think about, well, what are my benefits? Well, my benefits are going to be, if let's say I'm going to make $50,000, or my expectation is making $50,000 a year after I finish my education, and I'm going to continue to work for a good 20 years beyond that, then my benefits are going to be the difference between my pre-education income, which was $25,000, and my post-education income of $50,000. So I'm going to expect a gain of $25,000 of income each year that I wouldn't have had otherwise, over 1.05, this time to the sixth, plus plus 25,000 over 1.05 to the 25th. In this case, my PV is going to equal my benefits. Well, when I put both of these values into the same equation, have everything on the right-hand side, what I've really done is I've taken a look and said, okay, my PV, is it equal to my costs and my benefits? Recognizing that my costs are always going to be a negative value. So what is the PV that I receive? Well, if the PV is 0, then my costs equal my benefits, even discounted for time and some expected rate of return, and so I'm probably indifferent as to whether or not I make that investment. If my PV is less than 0, then that means my costs are greater than my benefits, and if I've used the appropriate R, or rate of return, then I probably shouldn't make the investment. And if my present value, or PV, is greater than 0, then it means that I should make the investment. I'm going to get some financial gain. It's interesting. Sometimes we'll find that we go through these kinds of calculations. We find our present value is less than 0, but maybe modestly less, $500 less, $1,000 less, and we go ahead and decide to make the investment anyway. That would suggest that we use the wrong R. So let's talk about what R stands for in this equation for a moment. R stands for a personal discount rate. It's the rate of return that you would expect on the money that you're investing. Because you're literally investing money when you're going into the education experience. Even if you happen to be using a student loan, you're still investing money. It's money that you've got today, or money that you're borrowing today you're going to pay back in the future perhaps. Or maybe it's your parents' money. Or maybe it's money from some grant resource or some scholarship fund. But nonetheless, it's money, and so we have to think, what rate of return do I expect to receive on that money? And that becomes my R. If one is very aggressive about their rate of return and likes to take lots of risks, then their R might need to be higher than, say, the 5% I've used in this sample. Or if they're extraordinarily conservative, they never take risks, maybe their R is going to have to be less than the 5% I've used in this example, maybe 2%. So in my stream of payments, in my B, or often referred to as beta, I'm including hard costs, opportunity costs, and changes in income. So let's go ahead and look at this simple higher education scenario I've begun to paint for us. We've got our initial cost, and let's say the initial cost in this experience is $3,000. Let's say there's an upfront cost that I've got in $3,000. Maybe that's excuse me, the relocation cost, going to the college I'm going to go to, getting into the new apartment, setting up my contracts, all of these different things. And I've got a cost of $15,000 in books and tuition. Let's say I'm going to be in college for 5 years. My current income, I said, was $25,000. My income while I'm in school is only $7,500, so the difference there, the change, is equal to $17,500. My future income I expect to be $50,000. So that change is equal to $25,000 over and above my current income. And I expect my career to last 20 years. So I'm going to have a total of 25 years, the 5 years of education experience, the 20 years of career length. And well, maybe I expect my career to be longer than 20 years, but I want to know that if I'm going to make this investment, then within the 20-year mark, I want to know whether it's going to pay off or not. $15,000 a year is a lot of tuition. Giving up $17,500 in income during these years seems like a lot to give up. And frankly, a $50,000 income to start with, that might be a pretty good income to start when you're just getting out of college. But over time, that's not a great income. It's a modest income. Hopefully you'll earn a lot more than that. But then I have to think about this rate. And I'm going to use a rate of 5% in this case, only because that's approximately the same rate that are being paid on many student loans. Your rate might be higher, your rate might be lower. This is considered a personal discount rate. So as I think about this equation, I have to think, well, what's the beta t going to look like to begin with? Well, my beta t for year 0 is going to be 3,000. That's the initial cost. And I'm saying beta t at year 0 because if a cost is incurred immediately, there is no time. It happens immediately. It's at time 0. My beta t for years 1 through 5 is negative 32,500. That is the $15,000 of tuition and the $17,500 change in income. And then my beta t in years 6 through 25 is going to be $25,000. As I go ahead and put this equation together then, I've got these values, and I'm going to then sum this equation. And it's going to look at first to be a little bit cumbersome. But don't let this bother you. And again, I would recommend you look at this part of the video, this segment, at least twice to get comfortable with this structure. But at first, it's going to look a little bit cumbersome. I'm going to have this equation that is this large equation here. And this is simply putting all of this together. So my present value is equal to minus 3,000 over 1.05 to the time value of 0. And anything over a value or to an exponent of 0 is going to be that number over the value of 1, because any value to the exponent of 0 is simply 1. So this negative 3,000 is simply going to be negative 3,000. And then I'm going to have for years 1, 2, 3, 4, and 5 a negative value of 32,500. And then in year 6, I'll have a positive beta t. It's the first year I'm out of school. Now I'm earning this $50,000 income, $25,000 more than I made before. I'm going to have this beta t of 25,000 in years 6 through 25. I see that this says 20,500. That should have been 25,000, just as it shows down here when I see the exponent of 25 here. So kind of a general form of my equation can look like this equation I've circled, but if I go ahead and expand this to every one of these terms for years 0 through 25, I'll have a separate term for each one of those years with that year's exponent giving us a representation for time. Well, if you look at this, each one of these is simply a value that can be calculated with a simple calculator. And if we do that, we can go ahead and find that what we really have is a stream of values that are going to add up to $106,823. And when we've added up to that, we find that our present value is far greater than 0. We should go ahead and make the investment. I would encourage you, even though it's not necessarily an assignment for this segment, but I would encourage you to sit down using this metric and identifying what your present value is, expected present value of your education experience. It's going to give you some idea as to the value of the human capital investment you're making. Certainly that value should be far greater than the cost. Excuse me, I keep coughing today. I apologize. Though we live in a time in which people have begun to value the income benefit of receiving a higher education degree, whether that's bachelor's, master's, or advanced doctoral degree, one of the things that we have to remember is that we have these doubts that are entering into our minds, our psyche at this point, because right now we find people coming out of higher education right after having gone through a fairly significant recession. We have a lot of globalization, a lot of deregulation. Initial wages for college graduates are probably less than they have been in prior years, or certainly prior to the 2008-2009 recession. I wouldn't allow that to bother you. Yes, you'll start out perhaps at a wage that may not be terribly impressive, but over time, you're simply going to build on that. And if you try to put together a present value equation thinking about your higher education experience, my guess is you're going to find that you'll have a significant present value. If you internalize the costs and the benefits, both in this equation, my guess is you'll have a value far greater than zero. Now, if you're only planning to be in school a couple of years, but your schooling is expensive and you're going to then only be in the workplace a couple of years, maybe that'll be difficult. If you choose to be in the workplace for another 20, 25, or 30 years, the greatest likelihood is, even if you have a fairly aggressive R, that your present value will be far greater than zero. So this is a way that we can value human capital investment using the production and income value, which we think of as in the present value sense of being present value is the sum of beta t over 1 plus r to the t.